So first, we recapitulate what we have discussed yesterday. Yesterday, we have discussed about the types of operand and types of operation. So you know about operand and operation. Operation means opcode and operand means a different variable. So the different types of variable you might have used in your C programming, like many times we use addresses instead of directly variable. We point to a particular address. Our variables sometimes numbers, like you are writing a is equals to 10, b is equals to 5. Sometimes our variables could be the character, like integer is equals to a, integer a, b, like this. Uh, so it could be the character or the logical data, like flag is equals to 1. And if for the particular condition you check the flag, uh, either it is 1 or 0. So these are the four types of operand we have seen yesterday. How the number we can represent as a positive number, negative number. For the characters, there is ASCII and IRA. These two standards are available. Okay. So these two standards are available. Uh, Types of operation. Types of operation means the opcode. Opcode means operation. What is the opcode? Opcode means the instruction that we have seen. Like suppose if you are writing add a comma b, for example. So here, this is your opcode. This is your opcode, and this is your operand. This opcode, you can call it as operation. Similarly, this your operand could be the variables. So we have seen different types of variables, like it can be your numbers, logical data, character, flag, and the operation, like instruction. So you might have written number of instruction in first year in CP. So you can broadly categorize your instruction in between these categories. So broadly you can categorize your instruction into like data transfer, arithmetic, logical. Maximum you have used these two types of instruction. Again, we can use for the conversion. Conversion you might have used some instruction for the input output, either to take an input, to display the output, system control, and transfer of control. So yesterday we have discussed about the data transfer, how the source, destination, and amount of length required arithmetic instructions are your addition, subtraction, multiplication, division. The logical is and or not, conversion, binary to decimal, input output. It is like either you are taking an input from the keyboard, your output will display into the output devices, could be the your monitor or printer, and for that purpose we use a separate controller like a DMA, then the system control to actually this mainly whatever the instruction you write in system control, it is for the operating system to control the system, uh, and the transfer of control like jump instruction, the branch instruction comes under the transfer of control. Okay, so yesterday we have discussed these two topics, that is types of opcode and types of operand. Now today we'll discuss about addressing mode and format. This topic is really very simple. You will have to remember diagram, and you can easily remember the whole concept. It is very simple. And even the diagram you can easily remember by the name. So what you have to do, you have to first remember these types only. If you could remember all these types, you can easily remember the complete topic. So by the name is addressing mode. So how actually we can address our operand. So it refers the way in which operand of an instruction is specified. How the different way in the instruction we can specify our operand. As we have seen, add is the opcode and A and B is the operand. So operand is what? Operand is our variable. So what are the ways are available by which actually we can specify our operand in the instruction? And these are so why actually these different ways, different types require sufficient now? But no, actually each mode having its own advantages and disadvantages. That things that we have to understand. And it is very easy. Simply by only reading their names, you can easily remember. Like immediate addressing mode, direct addressing mode, indirect, registered addressing mode, registered indirect, displacement index, and stack. So we'll discuss one by one. The first one is what immediate addressing mode. So the name is what? Immediate addressing mode. So as we have seen, opcode and operand. In a program also, in a semi-language program also, we have seen actually how there is the opcode and operand. So here is opcode is, for example, opcode is your add is opcode. This add is opcode, and the operand is given, for example, here 5. And here operand is given, for example, 5. Now in this case, if you see here, actually the why it is called immediate addressing, because directly here the value is given, like add 5 means this 5 value is added with the variable, the another number. So actually in our previous example in unit number 1, we have seen how actually we add a number. So there is an accumulator. Accumulator hold the number that you want to add, right? And for example, this is the instruction. So accumulator is holding one number, there is one number, and this instruction is executing. So add 5. And for example, the accumulator have one number. Accumulator have one number. So here what we have to do, what we will do here, in execution, this 5 will be added with the accumulator value, that is 8. So here actually operand is a part of instruction. So here this operand is the part of instruction. And this operand is adding with the value of the accumulator. So add a 5 to contents of accumulator. So here we assume accumulator holding a value 8 and this 5 value added with this accumulator. And this 5 is nothing but the operand. So why actually it is called immediate? Because immediately the respective value is specified in the instruction. The operand value is given in the instruction only. This is a part of instruction. So that's why it is called an immediate. So here we are not giving any kind of memory reference. Suppose instead of add 5, if I am writing add A is what? A is a memory reference, for example. So first we have to, the memory address is located and from the respective memory address you have to pick up a value, right? So that time you cannot say it is an immediate. Immediate means directly the immediate value, whatever is in the operand, the value is adding with the accumulator, whatever the value accumulator holding. So actually here we no need to provide a memory reference to fetch a data because data is already there, na? So actually the memory reference does not require here. The value is directly given. And if you are using this type of addressing mode, that is immediate addressing mode, because here you no need to map with the memory, the value is directly given in the instruction. Obviously, this type of immediate addressing is a fast. It works fast now because you no need to refer any kind of address. Directly you are considering the same value. That's why this type of addressing is a fast. But what is a disadvantage? The disadvantage is actually the size of number is restricted to the size of address field. We can say the limited range. Because whatever the address field, the size of address field provided in the instruction, only that much size is available for to store your number. This is a restriction. You cannot store a number beyond whatever the size available for the operand in the instruction. For example, if there is a maximum size of 32-bit, so obviously your number would be in between 32-bit only. This is the limitation because you are directly giving number here, na? And if here the maximum size is 32-bit, so your number must be in between 32-bit only. If you are here, if this size is only 8-bit, your number must be in 8-bit only. So this is the disadvantage with the immediate addressing. And here actually we are storing a value. So we know actually how actually we can store a value. In the computer, always we use a least significant bit. The leftmost bit is a sign bit. If it is a positive or negative, accordingly we have to set 1 or 0. So in 2's complement frame, your number save into the memory. What is another advantage is actually here we are saving a memory because only one memory required in accumulator and directly value is given. And because of this, cache cycle is also reduced into one instruction only. So the cache cycle in the instruction cycle is also reduced addressing, because multiple cycle does not require. Directly you are picking a value and adding with the accumulator value. So all these are the advantages with the immediate addressing. The next one is direct addressing. Direct addressing. So as per the name, if you look here, the diagram, you can easily understand the concept of direct addressing. So here the address will contain address of operand. In immediate addressing, instead of this address, there is a value that is 5. But here, this instruction holding address, for assume, suppose this address is here, for example, if you consider here, this address is 901, this address is 902, for example, this one is a 903. So actually these are the addresses of a memory. And suppose here the address is written that is, for example, 902. So here actually directly this is not a value. This is not a value like in our previous example. In our previous example, there is a 5. 5 means what? That is a actual number. Actual number is there. But here this is not actual number. This is what? This is the address of memory 902. So actually the question arises how the computer will come to know this is an address or a number. Because 5 is like a 902. Na? This is also one kind of number. So in the instruction actually there is the few bits are available which inform to the computer the type of addressing mode. By that type of addressing modes, it means the bits are set as per your the type of addressing mode. Yeah, either it is immediate or direct. You will find, for example, 111001. In this way, if you are considering 2-bit, you will get 2 combination. If there is a 3 bits are there, you will get 2 combination, and accordingly you will assign this combination to the different types of addressing mode. So this bit set in a instruction, and when actually your program converted, that time this information is provided to the computer. By this way, the computer will come to know which type of addressing we are using in the computer. So actually here, if you see in direct addressing mode, the address is written here, and this address we are mapping with the memory. 902 is there, so whatever the operand value is here, we are mapping by the address. Now here also you will get the advantages which are not available in direct addressing mode. If, for example, if here the value is 500, so this 500 value will be considered here. Suppose here the same is add address A. Address A is pointing to a 500. So whatever the value is in the accumulator, this 500 value added with the accumulator value. So in direct addressing, your effective address is equals to address failure, A. So this line you have to remember. If you observe you will find there is a small changes in this notation. Like it is effective address is equals to address field of A. So in bracket A. So here in earlier example add 5. Here you have to remember add A. A is for the address. So we are adding a content to cell to A. Add the contents of cell A to accumulator. So as we have discussed earlier, at whatever the address is there, for the respective address, whatever the value is there, operand value is there, that value will be added with the accumulator. So for that purpose, we look in the memory at address A for the operand, and that operand we will choose for the addition with the accumulator if you consider this instruction add A. So actually here in direct addressing, we use a single memory reference to access data, the single memory reference. Here we are not pointing out to a one memory address and then we are pointing to a operand. This type of situation you could not see in direct addressing. In direct addressing, always you will find there is a single memory reference. It is not the case you are referring to a memory and again memory referring to the another memory for the operand. No. In direct addressing, always there is a single memory reference, and from that single memory reference, you can access the data. So in direct addressing, you will get one kind of advantage. What kind of advantage you will get here? You no need to calculate your address, effective address. Because directly address is written, na? Directly address is given. So the additional work is not required to get the effective address. Whatever address is there, directly from respective address, you have to choose the value. But again, it having a limitation. What is a limitation? Limited address space. By indirect addressing, you will get a limited address space. How limited address space? So for example, suppose as we discussed in our immediate addressing also, for example, here there is the 3 bits are available. So using 3 bit, how many combination you can create? Assume it will become simple. For example, only 2 bits are available. So only 2 bits are available. So how many combination you can create with the 2 bit? 0, 0, 0, 1, 1, 0, 1, 1. So how many combination? 2 raised to 2. That is 4. So 2 raised to n. Right? So the 4 combination you will get here. So whatever value you have to write here, so if and there is only 2 bit, only 4 combinations are available. Only this 4 value you can write here. So suppose if there suppose here is a 32 bit. So how many value you can write here? 2 raised to 32. Only this much values you can write here. This is the limitation with direct addressing. Only whatever the value you can write in this field as per the number of bits are available, only that much of memory you can access. Only that much of memory you can access. So because of it depends upon how much the size of address field available. So limited address space. So this is a disadvantage with the direct addressing. Otherwise, this is also faster, but compared to the immediate addressing, it is slower. Because in immediate addressing, directly value is given over there. Directly you are choosing that value and you are doing addition. But in direct addressing, actually you are referring to a memory location, and from the memory location you are choosing a value. The next one is indirect addressing. So as I told you earlier at the beginning of the lecture only, by only the name, you can easily remember the whole concept. Why it is called indirect addressing? Because now if you observe here, the opcode is there, that is for example add, and the address is there for add A, right? But this address you are pointing to the memory, but the memory address again pointing to the operand. So if here, in our previous example, whatever the address is there, that address is for the operand only. But no, in indirect addressing, actually your instruction point to the pointer to operand, and pointer points to the operand. And in this way, the multiple instruction can access your operand. So the name is indirect. Why it is direct? Because directly this mode accessing the operand, but here indirectly you are accessing the operand. That's why the name is indirect addressing mode. So memory cell pointed to by the address field contains the address of pointer to the operand. So first you are pointing to the whatever the address is there in the operand. First you are pointing to the memory cell, and from the memory cell again you are pointing to the operand. So effective address is equals to A, because it is indirect. So look in A, find the address of A, and look there for the operand. So in this way, actually, we are looking the operand. So here, if you observe here, you will find difference here. Initially, in the first example, add 5 was there. Then add without bracket A is there because it is direct. But here it is indirect. That's why add in bracket A. So add contains of a cell pointed to by the contents of an accumulator. So whatever the value is there, first you're pointing out to that memory cell, and from that memory cell you will get your operand. Now, what kind of advantage you will get here? So actually, we have considered one example. In that example, here, for example, you have a 2-bit. Okay. So with the 2-bit, the 4 combinations are available. And suppose here is a 2-bit. So again here, how many combinations? 4 combinations. So 4 and 4. In this way, you can create a multiple combination, right? So a huge address space is available in indirect addressing compared to the direct address. Because in direct addressing, if the 2 bits are available, 2 raised to 2, it means only the 4 different addresses you can write in this field. But here, because it is indirect, here is few bits, and again here are few bits, and by both the combination, huge number of addresses you can create in indirect addressing mode. So large address space is available. 2 raised to n, where n is equals to word length. So as I am talking about how much the address space is available, 2 raised to n. But here, though your address space is increasing as per the word length available on the memory, because that combination is also connecting with your whatever the bits available in the instruction. Multiple memory access to find the operand. Again, this is a disadvantage. Multiple memory access. So multiple cycles are required. First, you have to access this memory. Then you have to calculate the operand memory address, or then you have to access the operand. So multiple time you are accessing memory, na? First and then second, to access an operand. But in our previous example, directly you are accessing operand. That's why it is a faster compared to the indirect addressing. But here, indirect addressing is slower. Why slower? Because multiple times you have to access your memory to access the operand. But what is the disadvantage? More number of address space is available in indirect addressing compared to the direct addressing because two combinations are available. So hence indirect addressing is slower because multiple times you have to access the memory. Now the next is registered addressing mode. It is similar to your direct addressing mode. If you see here, the registered addressing is very similar to this diagram. Only you will find difference here. Instead of memory, there is a register. Look. Otherwise, it is exactly the same. Registered addressing mode. Opcode, registered address, and here is the registers. Operand. So in unit number 1, already we have discussed on your processor, the different registers are available, and while your ALU, arithmetic logic unit, executing your instruction, so that time he stores your operand into the register one because the fast execution, right? So because of the register, the fast execution is possible, and on the processor, all these registers are available, and ALU choose a respective operand value from this register only. So here, if you will find, explanation is very similar what we have discussed in our direct addressing mode. Here, direct addressing, but the address is registered address, not a memory address. But the address format is the same way. That is a direct address. So again, here you will find a difference. Effective address is equals to R. And earlier, effective address is equals to A. But here, the R. So operand, because it is registered. So operand is held in register, name in address field. But again, we know these registers are limited number of registers. So this is again one kind of disadvantage. But in memory, the more memory is available compared to the few registers, right? On processor, there are few registers are available, but you compare them with the memory. In memory, there are more number of addresses, space, everything is available compared to the registers. But the question arises, so what is the use of register addressing? Direct addressing is good, na? Because more number of address space is available on memory compared to the register. But we should know the registers are more faster than memory. So even though there is a limited number of registers, so but according to as per our program, we can use this register addressing. But here, as the registers are small size, so very small address, limited number of addresses, as well as the another thing is a very small address field required. For example, suppose if you want to add R1, R2. By this way, actually, you can perform addition operation. Whatever the value you have moved into R1 and R2, you can perform addition on the respective register. And by this way, actually, your instruction size will be minimized. It minimizes the instruction, as well as the faster instruction fetch in register addressing. Because fetching is a faster in register addressing compared to the memory addressing. So multiple register helps performance. So actually, this type of addressing is helpful to improve the performance. And in assembly programming, you will find this register addressing in the program. So assembly programming or compiler writing, we use as register addressing. The same way, by only looking the diagram, you can easily understand. The same thing we have discussed in indirect addressing, register indirect addressing mode. So by looking this diagram only, you can easily explain. In registered indirect addressing mode, here the instruction, your whatever the operand is there, that instruction is pointing to a register address, and your register address point to the respective operand which is available on memory. So here the registers as well as memory both are involved in the registered indirect addressing mode. So first your instruction is pointing to the registers, and from the register you get the reference address of the memory. And by this way actually your operand can be accessed and returned to the processor while executing an instruction. So register indirect addressing. So effective address is equals to R. So it is indirect addressing. That's why you will find there is a bracket. In here, there is no bracket because this is registered addressing. This is not indirect. That's why you will not find in bracket here for the registered addressing. But in indirect addressing, here is a bracket because it is indirect. So these are the notation that you have to remember. So operand is in memory cell pointed to by contents of registers R. So in indirect registering, so whatever the value here, first your instruction pointing to the register address, and from the register address it will point to the memory address. Again here, as we have discussed earlier, by this way, what is the advantage of indirect addressing? A large address space available in indirect addressing, because you will get again two combinations here. One is from register and one is from the memory. So by this combination, large address space will be available in indirect addressing mode. One fewer memory access than indirect addressing, but actually this kind of addressing is slower because multiple times you have to access a memory. But compared to the indirect addressing mode, registered indirect addressing mode is faster because we know registers are very fast compared to the memory. Next one is a displacement addressing mode. Displacement. So here you will find opcode is there, register address is there, and the base address is there. So actually how we can find out the operand value? From the register address, you will get the respective register address, which point to the operand. But how you will get the operand address? When you will get the operand address when you will add with the address A. So whenever you will add with the address A, so here you will find both the values required, register value as well as address value for the addition, if you are doing addition. So first register point to the register and address A. First we have to perform addition, and then you will get the respective memory location. So in displacement addressing, actually how the effective address we can calculate? Effective address calculated by A plus R. In R is what? R is indirect. And A is current location. So address field hold two values, that is base value, and the second one is register that hold a displacement. So this base value added with the displacement or the vice versa to get the effective address in displacement addressing. And displacement addressing having a multiple type. And by their name only you can easily remember these types also. Like first one is relative addressing. Relative addressing means we relate, right? We relate first to get the respective address. So how we can relate? So like your program counter PC holding a address of next instruction that the instruction will going to execute. So PC having an address and A is what? A is the address. So when you will add A with the program counter, you will get the effective address. So here your address is relative to the next instruction. Next instruction that the PC have holded for the execution. And based on that, you can calculate your effective address. Next one is a base register addressing. In base register addressing, holds a displacement. A hold a displacement. R hold a pointer to the base address, and R may be explicit or implicit. So here, B is, for example, 2000, offset address is 20. So how actually the address can be calculated? By adding both the values, BA and offset address. So 2000 plus 20, physical address is 2020. Next one is index addressing. So many times you have used this index word, for example, in for loop, right? For loop having whatever the number in a for loop, each number having an index number, 0, 1, 2, 3, 4, like this way, right? In an array also you will find there is an index. 0, 1, 2, 3 start from the 0, right? So A is what here? Base. R is displacement or index. So how the effective address will be calculated? Effective address will be calculated by the A, your whatever the value is there, plus displacement, that is index value. For example, index is 5 and your value is 4, so 5 plus 4, that is 9, that is your effective address. So mainly this kind of index addressing is useful in arrays. And the last one is a stack addressing. Stack addressing is a operand is implicitly on top of a stack. So actually here explicitly we are not specifying any kind of instruction, operand, but implicitly whenever actually you are using a stack, we can perform operation on the operand. Like for example, suppose if you want to perform add, so you will push both the values into the stack, and when you will pop, you will get the addition of both the values in the stack address. I think we should stop here because this topic is over, and in the next lecture we will start instruction format. Okay, so today we have discussed addressing mode, and all addressing modes are very simple. Only the thing is you have to remember the name: immediate, direct, indirect, register, register indirect, displacement, and stack. And if you could remember their diagram, you can easily remember all the concept. Okay. So if you have any question, you can post your question into the chat box. If you don't have any kind of question, you can leave the session. Today's meeting over.